Good morning, everyone. My name is Andrew Chen. I'm here to give a brief update on my applied science project on aerodynamics and flying wings. It's been quite some time since I last introduced my project, and it's safe to say a lot has happened. As you all know, I teamed up with Adit's little brother Abhinav and his father, Mr. Ashish Shah, who both deserve a lot of credit as key contributors to this project. As the title suggests, we started off with what I call the development phase on paper. Andrew Firmage, who was essentially the most knowledgeable person on aerodynamic testing at our disposal, gave us the technical expertise to construct a simple wind tunnel. We had to clear all our dimensions, airflow theory, materials, even the type of fan we chose with him. But I guess we did build a sick wind tunnel in the end, so kudos to him. To be honest, I didn't really trust all the designs on paper right away, so I made some simple model representations of the wind tunnel out of cardboard. That took about 3 hours of hard work. I finally understood what I needed to do afterwards, which was cut out 8 trapezoids and 4 rectangles and put them all together. Marking all the dimensions took another 3 hours. You might be wondering, why did I spend so much time prototyping and designing? And my answer to that is, it's not really important how much tangible stuff you produce in the beginning. In fact, I would rather make everything make sense in my head before construction so that I don't have to build a second wind tunnel. So remember those cardboard models you might have thought were useless? Well, turns out they were pretty useful when we were putting the whole thing together. Everything was sealed together with an airtight adhesive found in common home repair and covered in electrical tape. The fan we kinda just slapped on with some airtight saran wrap and tape. Simple but convenient. All in all, construction took 4 7-hour workdays for a total of 28 hours of work in 3 weeks. So if you're looking for some quick motivation, I suggest finding a fifth grader who's doing more ambitious projects than you were in eighth grade to help push you along. This was actually the part of the project where I had a little bit of fun. Alum Alan Greer was kind enough to make a simple CAD drawing of Dave's flying wing in SolidWorks, which I 3D printed out into a cute miniature version which I could stick in the wind tunnel for testing. There's a hole drilled through the middle so it could be mounted on a tube and held in place with a screw. The whole piece is placed on a scale to measure the weight of any aerodynamic downforce the model generates once the fan is turned on. I didn't exactly account for the thickness of the walls, so the model is a little too wide. But check this out. My data still works.
Education, right? Yeah, they don't even know they're learning. Yeah.
The feelings are really subtle like this, and there are things reverse engineering of this. We have hex. This is what most photos look like, or most photos are composed of. This is also like is anyway.
So the scale was flipping out a little bit, but as you can see, my model still generates a decent amount of downforce. So I think it works. By the time you're watching this, I'll have printed out a better model using the resin printer with the correct dimensions. This ahead is testing a decent model in the wind tunnel, then making slight adjustments to the design in terms of shape and size to see how that affects its downforce. I also snagged a model of a life-sized wing, which I hope to have up and in the air for testing after I get components for it. But for now, it's just sitting on the shelf. If you guys have any questions or feedback, I would love to hear it and talk to you guys about it after I get back from the desert.